Good evening. Can you hear me? I hope you can. Welcome to the 2014 British Journal of Sociology Annual Lecture. My name is Nigel Dodd and I'm the Editor-in-Chief of the BJS. We've been running this series of lectures since the early 2000s with the intention of airing matters of great public interest as well as sociological significance by hosting an annual lecture which is then debated in a symposium published in the journal the following spring. This year's event builds on that tradition, and I'm delighted that we have Professor Troy Duster as our speaker tonight. But before I introduce Troy, I'm afraid I need to speak for about 9 minutes, unfortunately, but Troy knows this. I have a few important announcements to make. The first one is about the BJS Prize. This will be the third prize that we have awarded. Past winners were Claire Saunders and Anthony King. The prize is given to the article considered by the BJS editorial board to have made the most outstanding contribution to sociology during the past 2 years. It's published within the journal, of course. This year, I'm very pleased to announce that the prize goes to a multi-authored paper called The Whole is Always Smaller Than Its Parts, a Digital Test of Gabriel Tardé's Monads by Bruno Latour, Pablo Jensen, Tommaso Venturini, Sebastian Groin, and Dominique Boulet. This was published in December 2012. This highly cited paper contains a rich and fascinating discussion of Gabriel Tardé's social theory that seeks, among other things, to dispense with using notions such as individual or society. The paper is, as one of the reviewers wrote before it was published, a timely intervention that both expands on recent interest in Tardé's work and relatedly looks at the underexplored, underexploited potential of data visualization. We believe that the paper represents exactly the kind of provocative and original work that we strive to publish, which also speaks to a very contemporary debate about digital sociology. It is therefore, we think, thoroughly deserving of the 2014 BJS Prize, and congratulations to the authors. During the next few weeks, Bruno Latour will be making a podcast for us in which he discusses the aims of the paper and explains how and why it was written. When I told him and his colleagues that they had won the prize, only last week in fact, Bruno asked me to read out the following statement in this lecture. So here goes. I'd put on my Bruno voice, but I'll just stick to my own. So it says, "Dear BJS Board, we are very honoured by your award, especially because this is the first technical paper in English coming out of Media Lab we created 5 years ago to connect social theory and what is now called big data, but that should really be called, he says, smart data. The Media Lab had been conceived largely to understand what Gabriel Tardé had in mind when he claimed that he could quantify social connections with better tools than statistics. He was himself the head of criminal statistics at the Ministry of Justice, and his data set had been used by Marcel Mauss to feed Durkheim's book on suicide, a book where the said Durkheim was more than happy to trash Tardé's insights. It says here. So since 2004, I have assembled a multidisciplinary group with a biologist. It happens that bacteria are great for testing Tardé's theory, cognitive scientists, media students, and of course science studies scholars to see how we could operationalize Tardé with the web data newly available. But it is only with the help of 2 physicists and the Media Lab researchers that we've been able to see how the obscure notion of monads can be made more amenable to empirical analysis. There is, of course, he says, a long way to go. Once again, we are very proud and thank you very much for such an honour. Tardé vindicated by the Brits a century later. That's really great. Bruno. While I'm talking about prizes, I'd like to tell you that we plan on instituting an additional BJS prize for early career authors. This will be formally announced in due course, but it comes as part of a series of developments at the journal that are designed to ensure that we publish work that is not only of the highest quality, but is reflective of new and emerging developments within the field. We also plan to publish a series of special issues and special sections focusing on what we think is the most exciting new work in sociology, not only in the UK, but worldwide. We also want to play a part in the major public debates, and it is in this vein that I'm very pleased to announce that our forthcoming December issue will consist of a symposium on Thomas Piketty's hugely influential book, Capital in the 21st Century. While much has been said about the book already, our symposium is distinctive because it brings together contributions not just from sociologists, but from other social scientists, including political scientists, anthropologists, geographers, and indeed economists. We'll be publishing economists in the BGS for the first time, who are focusing on what Piketty's book means for their discipline. The symposium will include a reply by Thomas Piketty himself. It will be published online in mid-December, and all of the papers will be available for free. I have two further practical announcements to make, and then we can get on with the evening. The first is that there will be a reception afterwards, and you're invited to come and have a glass of wine and something to eat at our expense. Second, the Twitter hashtag for this event is LSEBJS. Please tweet away. Tonight's lecture is called A Post-Genomic Surprise, the molecular reinscription of race in science, law, and medicine. And it will be given by Professor Troy Duster, who is Chancellor's Professor at the Warren Institute on Law and Social Policy, University of California, Berkeley, and Emeritus Silver Professor of Sociology at New York University. Troy is the past president of the American Sociological Association, and he served as chair of the Advisory Committee on Ethical, Legal, and Social Issues in the Human Genome Project. He has published widely over a long and highly distinguished career. His many sole-authored, co-authored, and edited books include Patterns of Minority Relations from 1964, The Legislation of Morality from 1970, Cultural Perspectives on Biological Knowledge from 1984, Backdoor to Eugenics from 1991, and Whitewashing Race from 2003. Troy is no stranger to controversy. A New York Times interview with him, published in 2005, carried the rather fabulous title, A Sociologist Confronts the Messy Stuff. In the interview, he argued that, I quote, by looking at what's in the blood, geneticists avoid the messy stuff that happens when humans interact with each other. And he adds, I believe you can't be creating ethnically based medicines, which is what a lot of biomedical research is about, without also doing some sociology. Well, I think that's a striking and intriguing note on which to welcome Troy Duster to the lectern.
Thank you very much for the introduction and also for the honor of giving this invited lecture for the British Journal. This is actually a return to the LSE for me. My first sabbatical at Berkeley was here in London some 3 decades ago, and so I'm reacquainting myself with the LSE and seeing some old friends and old faces. Tonight's lecture is going to be about a topic of considerable controversy. And what I hope is that in the course of the evening, I can help illuminate some of the social forces that are shaping this controversy and ask you to join me in the session afterwards in expressing your own views and responses. In the world of science, the 20th century was often called the century of physics. And for good reason, not just the obvious ones of splitting the atom and nuclear fission, space travel, moon landing, but in some ways in the more prosaic sense of the air travel. On any given day, there are 10,000 planes circulating the Earth at any hour. Just a century ago, that was unthinkable. So the idea that physics played this vital role in our lives is a transparent one. One could go on, of course, the actual computer chip and its spin-outs, which I'll say more about in a moment as it relates to genetics. Well, as the 20th century ended, we began to hear rumblings from people in the biological sciences that the 21st century was going to be the century of genetics. And as if on cue, precisely at the dawn of the 20th century, 2000, the first draft of the Human Genome Project was completed, providing two kinds of important hopes, aspirations for the new century. The first was explicitly about medical advances, the promise and the prediction that once the map was completed, we would see the development of new kinds of therapies, new kinds of pharmaceuticals. We would reduce health problems that ravage the human experience, human condition. And we'd even go into something called gene therapy. The expectation was, once you map and sequence the genome, you'll be able to find ways to end problems such as, well, it was from beta thalassemia to sickle cell anemia, Tay-Sachs, hemophilia. Any of these diseases were thought to be within the range of what was possible once you mapped and sequenced. So when James Watson, credited with the co-discovery of the DNA, became the head of the project, he would go before the Congress and make these extraordinary claims about what this $3 billion project would produce. And the Congress acceded. Interestingly enough, of course, one of the things that became sort of the poster child of the new Genome Project was that somehow in the next short period, we'd be able to solve problems like Alzheimer's and Parkinson's, of course, cancer, of course, all the other diseases, heart disease. And I recall a meeting in 1992 attended by Nobel Prize winner Wally Gilbert. And Wally had a deep, resonant voice. And he would pull out of his pocket a compact disc like this and say, "In the year 2012, this is you, this is you." And what he meant by that was, you go to your physician, and you put this into this slot, and your physician would be able to give you information. And the aspiration was, find solutions at the genetic level, the molecular level for whatever ailed you. That was an extraordinary promise of a Nobel Prize winner just 22 years ago. So genetics, the 21st century science, or more precisely, human genetics. So a little sociopolitical context here to set the frame for what I want to say. Human genetics had been low on the totem pole of genetic science, for good reason. At the apex was, of course, plant genetics. We've been experimenting scientifically with plants for centuries, but in the 19th, 20th century, it became a high science. Obviously buttressed by interests which are business and corporate, but plant genetics was at the apex. You could experiment with plants, Mendel, and so forth. Next came animal genetics. You could experiment. You could, and we did breed dogs, animals of all kinds, cats, cattle. You could actually experiment and breed animals. But human genetics, well, for obvious reasons, you couldn't experiment. And of course, the life cycle is such that it takes a long time to even understand the manifestation phenotypically of a particular kind of genetics. And so human genetics was restricted in its understandings of human behavior to correlation. So you have Pearson's R. You have population geneticists working about, or twin studies. And that was the way in which we understood human genetics until the end of the 20th century. I've indicated, therefore, that the first hope, the first great aspiration, was that this new map of the human genome was going to be health salvation. But there was a second aspiration, a more diffuse political aspiration, which was loudly trumpeted at the off-cited White House conference in June 2000. That's when Tony Blair and Bill Clinton, along with the two heads of the Human Genome Project, got together at the White House, and they made this famous statement collectively. I think it was Clinton who said it. One thing we know from the Human Genome Project, there's only one race, the human race. And this articulation of the problem was laid out there as a kind of a shibboleth. Those who saw this as a big issue said, what a wonderful thing to have happened. At the level of the DNA, the quote was, there's no such thing as race. Indeed, Paul Gilroy, in that same year, 2000, published an important book in which he argued that the new science was going to place this situation of race into a whole new contextual frame. That in Gilroy's framing, the new genetics at the human level was going to do its bit to end the way in which we think about racial taxonomies. However, somewhat parallel to the famous Mark Twain statement about the newspaper article claiming that he had been found dead, Mark Twain said, rumors of my death are greatly exaggerated. And indeed, the rumors of the death of race in science, clinical medicine, and law are far from over. Indeed, there is substantial evidence that developments in several fields of inquiry related to molecular genetics for humans, that is, clinical genetics, pharmacotoxicology, pharmacogenomics, patterns of migration, forensic science, that these developments have actually served to reinscribe race as a biogenetic category. And earlier this year, you may have seen there was a big controversy where former New York Times science writer Nicholas Wade published a book and stirred a lot of anger. Wade claimed that much of human intelligence, thus much of what he alleged to be corresponding human achievement of the last several centuries, can be explained by differences in the biology of races. Europeans in general, he said, and Jews in particular, achieve so much more than other racial and ethnic groups because of their biogenetic makeup. It took less than 4 months for a group of 139 scientists, ranging from evolutionary biologists, population geneticists, molecular geneticists, to sign a document in which they denounced Wade's conclusion and said he had no substantial grounds from the biological genetic literature. It was published in the New York Times Sunday Book Review section, and it said unequivocally that Wade's thesis did not have the support of the leading scholars in the scientific community looking at these topics of human taxonomies. Now, Wade does indeed make extravagant claims. He exaggerates, he speculates, he goes all across the globe making leaps which are unfounded about colonial empires, the ascendancy of economic political systems, based upon what he asserts to be the biological basis of race. Nonetheless, one should not be lulled into the false conclusion that the new human molecular genetics has been a battering ram undermining the idea of the biological basis of racial taxonomies, or even a neutral bystander on matters of race. Indeed, I plan to demonstrate scientists from these fields have played an important and sometimes unwitting, inadvertent, subtle role in rescuing the idea of race as genetic. If we go back to the first decade of the Human Genome Project, 1990 to 2000, there was a mantra that all my colleagues were using. And it was, it doesn't matter whose genome we sequence. Any person, any human being on Earth could be the subject of the Human Genome Project sequencing. The reason, they argued, was that we're all so much alike. It doesn't matter. It could be a Laplander, northern Finland. It could be someone from South Africa. It could be an Aboriginal. It could be a European. The mantra was, it doesn't matter. We're all so much alike. However, as early as 1999, there was a development that could have caught our attention. Science magazine published the following piece by Evans and Relling. And what they said in this period, 1999, right before the map was finished, was that all polymorphisms differ in frequency among ethnic and racial groups. And this diversity dictates that race be considered in aiming at, looking at genotype, phenotypes, disease, toxicity, and so forth. So, here we have the beginnings of the battle. What's going on here? We have, on the one hand, the head of the Human Genome Project and all the allies saying race is of no consequence, and yet, quickly, we turn to something called human difference. Well, let me try to explain quickly, and without any technical requirements on your part, what's at issue here. Take a little bit of a stretch, but not much. Why the turn to difference? Well, the geneticists were correct. We are 99.9% alike at the DNA level. That's true. Okay? But there are 3 billion base pairs. And therefore, that 0.1% has a funny translation. That means for any 2 people in this room, there are 5 million points of difference between you in your DNA. Inside your family, it's true, and it's true across the globe. So turn this on its head. We're all alike, 99.9%, but there's something called single nucleotide polymorphisms. This is the famous double helix. You've all seen this picture, and you can see at the very end, it's a graphic in which that you see the snipping apart of the double helix, and once it's split apart, you can put it into a machine, and that machine will give you the following. This is an actual graphic of someone's DNA sequence at a particular point on the chromosome. Now, here's what they meant by we're all alike, except. If I took any of you in this room and took your DNA at this chromosome, at this juncture, and put it on top of this slide, it would be a match at almost all points, except those 3, and possibly 2 or 3 of your own. So these are the 4 famous nucleotides, A, C, G, and so on. And they recur over and over again in a common way throughout the sequence that you have and that I have. And for the most part, the overlap would be complete. But about every 1,000 points of the genome, every 1,000 points, there's a little blip. One of those nucleotides is not the same as it would be for the next person. That's called a single nucleotide polymorphism. You'll hear it often referred to in this field called SNPs. So here's a typical situation across the globe. Doesn't matter what, again, they were right about this. Finland, doesn't matter. Australia, anybody has got this same sequence except for these 3 points. Well, what's this got to do with difference? Just because there's a difference doesn't mean it's going to make a difference manifestly in your phenotype, in your expression. So you might have any one of these differences. That makes no difference for its expression. But it might be that one of those differences is at a coding zone, and let's say it's where the blood might clot. And that one difference could mean that you could become, you could have hemophilia. So a single point of difference could make a huge difference in your life. Now, back to the point. Overwhelming commonalities but 5 million at least points of difference. Same year as the announcement of the Human Genome Project's end of race, we have a supercomputer from IBM to solve the mysteries of the human genome. The machine has the capacity to move at 7 trillion mathematical calculations per second. And suddenly everything changed. The search for difference became extremely important at many levels. It's going to influence everything from medical work to forensics to how we think about evolution. This whole notion. So how did we come to this situation? Where I'm going to argue in a moment that the field of molecular genetics at the human level has come to represent a framing of the problem, which says the reality of race lies inside the body at the DNA level. At the surface is really not as important, but it's what's going underneath. Okay, here's how we came to this situation. There are two quite separate developments which have converged in the last decade to concretize, literally, this cascading phenomenon which I've called the molecular reification. Now, one part, these parts could be pulled apart, and one part on its own wouldn't have the impact, but the two parts together. And the metaphor I like to use is crystalline phenol, which, if lying by itself inert, doesn't cause anything to stick. But if you put something together with it called a hardener, synthesizer, it will become super glue. So two inert issues kept apart, no problem. And my metaphor is going to be, that's what's going to happen with racial taxonomies. Part one, the Minority Health Act of 2000. What it did was to direct the NIH in Washington to make sure that in empirical studies of whether it was cancer, heart disease, asthma, diabetes, that you had minorities, that you could no longer have a study which only had white males. Women were making the claim that they should be part of these studies, but the issue became, for this particular act, the assertion that if you wanted to get funded from the federal government, you had to have a population which included minorities. And in the United States, that of course would mean Asians, Native Americans, African Americans, and sometimes other groups. But you had to at least acknowledge in your research design that you had made the attempt. So what did this mean? Well, let's say you are doing a study of prostate cancer, and you find empirically that in the United States, as you report your data back, African Americans have twice the rate of prostate cancer as do whites, and they do. And you're a geneticist. You report your data out, prostate cancer rates are double among African Americans. What's your toolkit? Well, the framework is the work that you do in the lab. The first thing you think about it, well, it must be genetic. Well, the good intentions, the idea was to have reduced health disparities. We have to know what the territory is. We have to survey the terrain. Then we'll be able to introduce legislation or interventions or medical treatments which will reduce disparities. So these next few slides are going to sort of dramatize the notion that race was not a dead issue. So you can read this. I won't read it. Okay, part one, this is not an uncommon phenomenon, by the way. In the empirical work, you'll find racial differences in outcomes. The question is, why? That's the question for the scientist, the social scientist, the epidemiologist, the common sense actor. Why these differences? Well, if you sample two populations which are racially different, and you tell the computer to go and find differences, they will. And so that's what happened, for example. Let's take the case of hypertension. In the United States, African Americans have a higher hypertension rate than do whites. Now remember, the NIH has enjoined these researchers to report data back based upon these taxonomies. So, we start to get these kinds of statements early on. Better understanding of molecular basis of ethnic differences, we're going to help us have individualized therapies in medicine. So you have this kind of contradiction. On the one hand, we're going to look at population differences. We're going to get to individuals. Now, look at this language, post-genomic. White patients require higher warfarin dosages than do Chinese, Asians. Where's this coming from? Well, it's clinical information, clinical trials, but in that period, everyone would make, this is part of the conventional wisdom, it was part of the textbooks in medicine, it was part of what you understood to be the case, that there were these differences in coagulation. Then the first big controversy. In 2005, the FDA approves a drug designed for African Americans, explicitly, the first drug ever approved for an ethnic or racial group in the United States. Now look at the framing, however. It's not just about hypertension, it's saying, well, there are distinct genetic pathways, explaining why blacks have higher rates of mortality for diabetes, cancer, and stroke. And now the paradigmatic fight. Look at that last phrase. Up until now, we thought it was poverty. Now we know it's genetic. Now, hypertension. If you look at this graphic, you'll see something that's rather striking. Right here it says US blacks. And you see it's a very high rate of hypertension. And right here you have US whites. And they have a relatively low rate of hypertension. Relative. If you stay inside your own country, and you think of this in terms of the racial taxonomies of your own country, you'll make a huge mistake as a molecular geneticist. You will conclude that it must be inside your own country. This hypertension study shows that blacks are different than whites, must be biogenetic. And many of my colleagues write papers saying things like, we held class constant, we found differences between the races, must be genetic differences. All right, this is what I call the common unwarranted leap between these two. However, Richard Cooper, the study I referred to that produced Bidil, the first drug aimed at people of racial categories, that study was of a 1,050 in. Only 1,000 people were involved in the study. They were all African Americans, no comparative data. Richard Cooper, on the other hand, the author of this study, went around the world, 8 different nations, 80,000 subjects, hypertension. And what does Cooper find? That the highest rate of hypertension across the globe in these 8 countries, the highest rate is Germany. And the lowest rate is Nigeria. Now, if you're staying inside your own borders and you don't see that, you'll think that the answer is genetic, or you think it might be. And that's where Bidil comes from. Again, we're still in 2005 here, and now we're going to see what the people are doing in the scientific literature. Nature Reviews Genetics, March 2005. These ancestry issues have implications for how we're going to develop drugs. And here's the language from that piece. It says, pharmacogenomics, well, we got to move over to Asia. Why? Because the Human Genome Project was mainly a Western phenomenon. So we have a pan-Asian consortium in which they put together all these nations. What do they have in common? They're just not Western Europe or the United States. They happen to be in that part of the globe where people ordinarily would think of themselves as national groups, but now it's a pan-Asian consortium because the category has become racialized. It's become Asian. What do people from Nepal, Taiwan, Singapore have? Well, they happen to be what? Now, here's the language from that study, from that famous article. It says the goal is to uncover the breadth of diversity within Asian populations, to focus genomic medicine on Asians. That's highly racialized language. It is this last sentence that I think I want to draw your attention to. Because what we're going to be hearing about in the next period is personalized medicine, personalized genomics. And yet what's happening increasingly is that we're talking about interpopulation differences. And this language is explicit. It says, let's turn this particular framework in the direction of interpopulation differences. A late-stage cancer drug, Eresa, was going to be launched worldwide. Why? Because it turns out that this is one of the most common cancers and the deadliest of all cancers. 1 billion annually was going to be the strategy. So AstraZeneca has this set of trials, but it's a bust. It's a bust. And it didn't work very well. U.S. Food and Drug Administration was going to pull it from the market. But they went back into the data set and found that among Asians, there was some effective late-stage lengthening of the life cycle over about 7 or 8 months, give or take 2 or 3. Wasn't dramatic, but enough to turn AstraZeneca towards Asia. My colleague in the audience tonight is Dr. Shirley Sun, who's working on the Pan-Asian Consortium, and will have a book out on this topic soon. So here we have it. Now AstraZeneca says, let's target these drugs to populations which can be conscribed in terms of these, what? Ethnic and racial categories. And we should be doing more to develop these drugs from the start. Flash forward now to the present. And now I'm going to give you some information which will clearly indicate how far we've come from the 2000 White House conference, which said the end of race. This is how far we've come. Something called admixture research. Now, admixture is a strange term in human genomics because it assumes that people are mixing who otherwise would not mix. And they come from different backgrounds, which one could even think about, as I'll show you in a moment, as 100% purity. So here's the language. Just a month ago, this was published in the Journal of Allergy and Clinical Immunology. So they're trying to make a difference between Latinos with different backgrounds racially and Latinos who have an African background, admixed. They're going to have a different outcome than those from other kinds of background, Native American. So we demonstrate ancestry influenced by differences in minority status. 5,000 minority kids, and asthma rates are highest in Puerto Ricans and lowest in Mexicans. So when you have Mexicans with more Native American ancestry, we're going to have a different outcome with respect to asthma. So now admixture has become a huge issue in human molecular genetic research on health issues. If you go into your Google Scholar or just Google and look up admixture research, reams and reams of reports coming out now on admixture. Now, let me turn to what is maybe somewhat humorous, but I'm going to make a serious point out of it. You can go up to the web now, to Ancestry.com, and for only $99, they'll give you an ancestry test. And it's going to come back, it's going to give you a proportionate ancestry. Proportionate Caucasian, proportion African, Native American, and so on. So look at this, I'm not sure you can see from the back of the room. This is Vanessa Williams, who is being advertised because she went to them and got her DNA, and it says, give us a little context about your discovery. And here's what she says. We ended up doing 2 stories on my father's side, and here's what my DNA shows. 23% Ghana, 17% British Isles, 15% Cameroon, and so on. Now, I can't wait to go to Ghana or Cameroon, or opportunity to see the customs, what's all this relationship between me, because the genetics is now determining the resonation of the human experience. How does it feel? Well, you know, I didn't know about this. I called my mother. Understood about genetic makeup. What do you think this information is important? Well, I'll tell you, you know, my mother told me when I was a baby, she told me about some of these blood issues. But now we've got the DNA. We've got the science. Another part of this story, I'll try to get to this in the next short period, has to do with what we mean by admixture, and in particular, an increasingly popular technology called ancestry informative markers. And I'll go into more detail, of course, in the actual journal article, and I can't do justice to it tonight. But I'll give it a short try. Here's what happens. These students give their DNA to this researcher, and the DNA comes back, and he tells students how much they don't know about themselves. To measure mixing, the importance of racial backgrounds, and what it means to be an American. So this person says, I thought I was 50-50, half black, half white. The test comes back, I'm only 42% African. Where is this coming from? Where is the idea that somehow deep inside of you is the real answer to your ethnic racial background? Well, this is not just entertainment. This is also going to be a question of who's entitled to certain resources. What the Human Genome Project spun off was this idea that you can go into the DNA and find out who actually is in belonging to one or another group. Now, we're talking here about money. When you have this kind of money floating around, then the really question comes up in a serious way, who's in and who's out? All right, I'm going to get to ancestry markers before I finish. So now we have companies where you can send in your DNA, and they'll tell you just how much of an Indian you are. Research question. Who's related to whom? How far back do they go? In which direction? Well, Orchard is a company will give you answers. This is no longer just entertainment. But let's take the category Native American. And Kim Tallberry just published a book called Native American DNA, which is an excellent book which I strongly recommend. And what she says, look, the scientists assume these categories. It's only upon close investigation at the ethnographic level and the historical social level that we can assign people to categories called Chippewa, Cherokee. At the same time, someone, again, you take a look at it yourself. I won't read it. The last sentence is important. So now I come to the major point I want to make about how and why this research is interesting, sometimes inadvertently infusing the category of race into our understanding of what's, quote, real. But before I do that, let me leave the PowerPoint and come to the point, which is if I put all of you in the category called A on this side, and in the middle section B, and on the far section C, and I took your DNA and I put it into one of these high frequency output machines. And I told the machine, let me go back to my first slide. I told the machine, I'd like to sort so that group A has a 30% difference in the frequency of certain nucleotide SNP patterns than group B. And I would tell the machine, I want 30% difference in the frequency of the nucleotides for you. And with 5 million points of difference, a machine will do that. And it will come back with a definitive answer. Now remember I said 30%. Why? Because there's no such thing as the nucleotide that's only for one group. We're talking about the frequency of a biomarker, the frequency of a SNP, and not whether it's absolutely in group A, B, or C. Now that's critical to understand the point I want to make about reification. So you got A, B, and C, and now the machinist tells me that you have differences at this level of the DNA. And you would appropriately say, so what? What possible utility is that information? Why should I care whether group A, B, or C has different frequencies of nucleotides in the genome? And you would be correct. But suppose all of you sitting over here were Asian, all sitting here were European background, Caucasian, and all there sitting were African. You might conclude that you discover the genetic basis of race. Got it? The machine will find points of difference at the 30% level. It's what is used in admixture research. And once you have that, that's how Vanessa Williams gets to say she's 11% Finnish and 20% Ghanese and so on. What could she possibly mean? What could you mean when you say you're 20% of something? It means you have to have a notion of 100% by definition, right? If you're any percent of something, you have to have a notion of what's 100%. What's 100%? And I'll tell you what it is. It's when, and this is the essence of admixture research, which is going on all over the world right now. You take a sample of a population, and in my case, A, B, and C, now let's say, in case A, I want to make sure 4 of your grandparents were from the same background. So, for example, Asian admixture requires that the Asian in the sample have 4 grandparents who are Asian. It's as simple as that. Caucasian, 4 grandparents who are Caucasian, and so on. That's the baseline. Then you collect, let's say, 2,000 people who fit that category. 2,000 in A, Asian, 2,000 in B, and 2,000 in C. And then you whir the machinery, the supercomputer, and you tell the machinery, we want 44 markers which appear at a 30% higher rate here than there, and so forth. That's how they do this. And that comes up with a figure that they call the 100% Asian, or the 100% Caucasian. Now, you'd think, because of the problematic character of how this is unfolding, there would be a lot of caution in using admixture research. There is almost no caution. I have given you examples, but they are replete in the literature of how it is unproblematic where those doing this work take the taxonomic system which is provided by either the census or by a few researchers who have done this basic work in admixture. It would be, quote, harmless if it's only looking at Vanessa Williams and whether she wants to go to Ghana. But we're talking now about whether you're developing medicines for people. Admixture research, you saw the slide from the area in which I work, in the Bay Area. That slide is from the Bay Area. It's about delivering medicine to asthma patients based upon their admixture. That is the molecular reification of race. So, ancestry informative markers. And I'm coming to a conclusion. How do they come to be called ancestry informative markers? Well, I just gave you an answer. It is more highly developed in some literature, which I'll refer you to in a moment. But it's a formula. It's a statistical framework in which you make a determination based upon frequencies, who's in and who's out, and in particular, who's 100%. I'm going to skip through to my conclusion here. I don't have time to go into the forensics, but you'll see here that there is a body of work which is making the assumption that from the DNA, one can infer ethnicity and race. Crime scene investigation, which you see all the time on television, will soon move into this zone of using DNA patterns to infer the race of the person. And there's now something called molecular photo fitting. And that's even more down the road to phantasmagoria in that, well, they take the DNA and find certain elements, let's say red hair. You can actually do this with red hair. There's actually a particular part of the genome that they conduct, but they're doing a lot more with it. All right, I'm now moving to get to my conclusion. The molecular reinscription of race. Pharmacogenomics, which I spent some time on, and here the most important work is by Pilar Osorio, race, genetic variation in the haplotype map. Ancestry testing, the most important work is by Duana Full-Wiley, the molecularization of race. National genome sovereignty. What that means is that many countries around the world are now deciding they want their own human genome projects. India, for example, has its own national genome project. Mexico, Iran, and you saw the Pan-Asian Consortium. So around the globe, this is a national phenomenon. And the idea is that we want to interrupt biopiracy. We want to have our own genomic information. We don't want the West coming in with their pirated information, pills that they didn't really develop except by coming to our country. We, in other countries, are not going to have our own genomes. And finally, forensic science. Jonathan Kahn's Race, Genes, and Justice, in which he talks about how this is influencing the forensic sciences, again, in the last short period. My purpose here has not been to demonize those using these technologies, but to alert my fellow social scientists to a development that requires an effective challenge. That requires an effective understanding of the technology. This is not that complicated once you understand what's happening. And some of my colleagues who've done excellent work in this world have done it by going into the laboratories of those doing this research on admixture and reporting out how they're doing it. So I'm not suggesting anything that's nefarious. It's more, as I said at the beginning, it's more the kind of inadvertent, subtle subterranean movement of science because of the phenomena where you're told you must report data out based upon race, ethnicity. Once you get into that zone, and once you have admixture research becoming a key element of the project, you will have the molecular reinscription of race. Thank you for your attention.
Okay, he's ready. So we have the ushers. There's a question, two questions up there on the left. There's the chap in the blue shirt and the person behind him as well, please.
Yes, one quick question. I'm quite curious by the terminology these scientists use, like difference. So I wonder whether that terminology not itself reflects a postmodernist or multiculturalist project with its own emphasis on difference rather than universalism or liberalism or human rights. So I mean, is this the continuation of cultural relativism, postmodernism in the style of Derrida? Or God?
Could you say what you mean by if it is a continuation? If
Yes.
this kind of research?
Yes.
Mm-hmm. I'll take two or three.
Okay, and the next, yes, please.
Yes, what is race and what is ethnicity?
And
Okay,
happy?
I'll take one more.
And one more, please.
Hi, Troy. Nice to see you. I wanted to ask what you think. I accept, all of your arguments, very detailed research on this. I was wondering what you think the motivation is to continue with this racial agenda in science. It seems to be an idée fixe, going back to scientific racism in the 19th century. So what is the motivation to perpetuate this?
Okay, I'll start with some answers. I'll start with the last one. In some ways, it's easiest because I tried to address it. That is, it's not so much that people are to be characterized or certainly accused or blamed for being racist. Quite the opposite. I'm suggesting, and there's a lot of evidence for this, that many of the people who are involved in this research come to believe that what they're doing is good for those people. So that the Asian Consortium is all about doing research that's going to help Asians because the Human Genome Project and the West has ignored Asians. The same is true for many of my colleagues. The Bidil study is a great example. Bidil is this drug for black people. And in the United States, black hematologists, cardiologists, were in favor of Bidil. Now you might say, well, why? Because they argued that white America has ignored black people's problems. And here we are, cardiologists, we're going to have a drug designed for us for a change. That's their language. So, Colin, the answer is in part, the people who are doing this will say, like Bouchard at San Francisco, he'll say, we've been ignored all these years, we Latinos. We're now going to do our own research. So Bouchard and his colleagues, many of them are Latinos, doing work on Latinos. So it's not a 19th century version of racism. It's a kind of extraordinary transmogrification. You can call it post-structural, post-modern, whatever way you want it. But the point is, things have come together, what I called this hardening of the glue. On the one hand, you've got the requirement to report data out based upon ethnic racial categories, which I'll come to in a moment. And you've got the hardener called the computer-based identification of admixture. So that combination is devastating in terms of reification. Because now we've got people saying, well, we've got these data, we were required to put it out based upon racial categories, and we understand that cancer is a huge issue, so we're going to show people that we do care about black people and cancer. We're going to have a drug designed for them, as opposed to a blockbuster drug. I'm sure you know, Colin, that the big issue here in the last period with pharmaceuticals is blockbuster drugs are falling by, and we're getting now population-specific drugs or disease-specific drugs, and that's what's happening. So again, I don't want to characterize my colleagues as demons who are racist. Quite the opposite. Many of them think of themselves as anti-racist. Now, the question about race and ethnicity, what's race, what's ethnicity? Well, I'm a sociologist by training, although I spend a lot of my time talking to and spending time with geneticists. Race is a highly variable concept. If you go back over at least the last 2.5 centuries, you see it has gone through about 30 important iterations. Only in the last 70 years have we come up with the big 4 or 5. If you go back to the 1910 period, there was a Jewish race, a Syrian race, an Aryan race. That collapsed. Why? Because of social political issues, not because of biology or genetics. Because of the social structures of racial privilege. Race has to do in part with power. And once you understand that, you'll understand how over time races changed. The Irish in America in the 19th century were regarded as a lower race. The literature from 1870 to 1900 is extraordinary in its racialization of the Irish. Come the 20th century, the Irish become white. There are several important books on this topic, how the Irish became white. There were signs up in restaurants saying, no coloreds, no, and no Irish need apply. So that's race. Now, ethnicity is more complicated. Why? Ethnicity is it's also a relationship. I should have begun there. Race is a relationship. So if you're in Europe and you're Serbian and Croatian, that's who you are. You come to the US, you become white. If you're in South Africa or in the middle of Africa, and you're from Ghana or from the eastern part, you're from Ghana or you're from Zanzibar, you're from your name, that's who you are. You come to the US, you're black. So situation and relationship define the nature and character of the taxonomic systems in which we live. Ethnicity. Ethnicity is a funny term. That's all about power. What's an ethnic group? Well, if you're in your own country and you're Albanian, you're an Albanian. But if you're in the United States or in England and you're in a little community, you're called an ethnic enclave. You're an ethnic group because you're out of your own country in another country. You're not an ethnic group in your own country. You're a native. You're a citizen. That's who you are. Leave your country and get involved with your own people in a group. You're an ethnic group. Now, what does that mean sociologically or anthropologically? It often means language. Sometimes you could add categories like culture, religion, social. I mean, all these things go into ethnicity. But the important point I want to make here is that ethnicity is a relationship to power. Now, imagine a category of an English ethnic in the colonial empire of the last 3 centuries. What you find, rather, is that the English, with all that power, call other people ethnic groups. You don't actually find much in the literature ever describing the English as an ethnic group. Why? Because they had a colonial empire. I would go on with this, but I think I've made the point that ethnicity and race are a relationship. They are a relationship, and they change over time based upon the politics, culture, and power that you have. Sure.
There was the first question about multiculturalism.
Oh, multiculturalism. There is, of course, an element of this question of multiculturalism in what's happening. There's a wonderful book by Stephen Epstein called Inclusion. And what Epstein points out is that up until about 1960, 1970, there was a standard phenomenon called medicine. It was based upon what research had been done on middle-class white males in the United States. The assumption was that that medicine was a universal. The last 3 decades of the 20th century, beginning in the US but now spreading around the globe, we're now finding inclusion. Multiculturalism, you can put it that way if you like, but we're finding the taxonomic systems being rendered, that is, center or core periphery, if you want to use Wallerstein's term, has been deconstructed. And now here are people saying, no, what we're going to be doing here is having medicine for a lot of different groups. So medicine has now been deconstructed, so the master category is no longer a single pill, but whether a certain dosage of pill is good for males or females, young or old, children are now being administered different doses, and now ethnic and racial groups. So yes, if you want to put it in that framework, you're now finding medical sciences, clinical medicine, pharmacology, toxicology, clinical medicine, all of them responding to an increasing consciousness of diversity in the society. The thing about Epstein's book that's wonderful is that he shows that it doesn't have to be this way. There are many ways to categorize populations. Why do we choose ethnicity and race? Why don't we choose, for example, with obesity, levels of obesity? Why don't we choose with cancer, who has prostate cancer, who doesn't? Wouldn't that be the right category? I want to do a study of prostate cancer. So rather than talking about blacks and whites and their cancer rates, you do a study of those with prostate cancer. And that's the study group, and you contrast it with those who don't have prostate cancer. That's the right taxonomy, isn't it? Why are you looking at blacks and whites? Hypertension, the question is, who's got hypertension? Let's look at that. That's a good taxonomic system. Why do we have special medicine for people with high hypertension who happen to be black? Okay.
Plenty of hands down. So in the second row here, person in the red.
Hi, my question relates to something that I think you kind of touched on in terms of academia, or rather academic performance and outcomes based on race, and I was hoping that you could delve a little bit into it and whether you believe that race would be the explanatory variable in terms of academic performance, or whether you feel that it's the response variable, and where you think that they're going in terms of genetic, I guess, differences and racial academic outcomes.
Okay.
Okay, yeah, and in the middle, right in the middle of this block, please.
My question picks up on your comments about Epstein's work and what you were saying towards the end of it, and it's really about what is to be done in the face of these developments.
What has he done?
No, what can be done in the face of these developments. And I'm thinking particularly, given the arguments, as you outlined, between scientists themselves, some of whom are arguing that in the name of defending the interests of particular groups, in the name of equality and the acknowledgement of diversity, they feel the need to continue this kind of research. So how do you argue with that, and how do you oppose it?
Actually, I should probably take these two now.
Go ahead. Okay. Yeah, he's going to answer that.
On that question, what scientists are doing is trying to get published. And if you have prefabricated categories, which are already there in the census or in clinical medicine, that's what you begin with. You don't begin with groundbreaking research at the core of the scaffolding of the problem. You can't. You want to get published. So you take already created data sets, and you then take a look at differences between asthma patients of a certain kind, and you get published. My colleagues who really get into the weeds of this topic find themselves mired in a problem which they have a hard time getting published. So part of my answer is straight out of the sociology of science. It has to do with careers. And young scientists need to publish right away. They need to publish 2 or 3 or 4 articles every year they're out of their PhD program. So ask them to deconstruct the whole architecture of thought behind race is never going to happen. Your question was, what can we do? We have to step way back from the issue of what motivates those who are publishing, because I know what's motivating them. They want to get a promotion or tenure. They want to keep their job in the pharmaceutical industry. And how do you do that? You get published. So it's circularity. Publishing, publishing, publishing. I think the answer, what needs to be done, comes further back in the process. It has to do with the way in which the Institutes of Health in Washington or whatever funding agencies are engaged in have to, I think, step back and raise questions about how to fund and then what kind of research. The first question was about race and education and whether or not, well, let me just tell you what I think about that topic and you tell me whether I've answered your question. It is the case that across much of the world in which African Americans are the minority group, and they're in a situation where there are whites or other groups, the performance educationally is lower, all right? If you, again, stay inside your own country and you say that, you see that, you do what I call the unwarranted leap. Because what often happens, and I mentioned it in my talk, you'll say things like, we held class constant, we found racial differences, must be genetic. That's a routine framing. It happens in other areas besides education, but it's a routine unwarranted leap. And the best way I can respond to that is to give you an example about holding class constant. So it may be circuitous, but you'll see where I'm going. One of the phenomena with respect to forensics is high rates of crime among black people in America, okay? And high rates of arrest for certain kinds of activities. All right, so here's what is an issue with holding class constant and finding genetics. I have a nephew who took his PhD at Berkeley in engineering and computer sciences. He lived with me for a period. So he had an advanced degree, a high-achieving, high-performing African American. He would occasionally, when he lived with me, this was about 15 years ago, occasionally he asked to borrow my new car. And when he drove into Oakland, on each of 4 occasions, he was stopped by the police until he stopped asking to drive the car. I didn't know why, but about a year later, it came up, and he told me what had happened. Now, across the street, I have a colleague who's also a professor at Berkeley, who has a son about the same age as my nephew, who borrows my colleague's BMW, a very nice car, and has never been stopped. Now, here's what's happening. You hold class constant here. We're across the street from each other, and yet race is making a difference in the stopping and arresting. What's at issue is the behavior of the police. Yeah? But if you're looking only at the surface of it, and you say the arrest records of blacks are much higher than among whites, and you hold class constant, you're going to make a huge unwarranted leap. The same is true for educational attainment. So many other factors are at play in educational achievement than the skin color of the person. They live in an environment which is extraordinarily stressful. So one of the things I didn't mention here is work on hypertension among blacks and how blacks of the same social class have higher hypertension rates than do whites. One of the outcomes was we're going to get a particular drug for black people. But in fact, what could be happening is the stressors in the environment. A white person goes into a fancy store, and they're just shopping. A black person goes into that same store and is followed around. Stressors. So what's happening, like in my example of the police and my nephew, it's not the skin color of the person or their biology, it's the reaction to their skin color and their and therefore the assumption is that they must be performing poorly. There are many other examples of this in education. There are remarkably interesting books written about this very topic. And I don't have a better answer than what I've given you, which is when you hold class constant and you find racial differences, the leap to the biological is a fool's errand.
Okay, we haven't been this block yet, so there's two in the fifth row back, please.
Thanks for your talk. I just wanted to ask if you could tell us a bit about genetic studies in relation to intelligence.
Genetics of intelligence?
Since 2000. If you could update us on if there's been similar developments in relation to intelligence.
I'm not sure I understand the question. The genetics of intelligence with respect to?
In respect to genetic differences, have there any been, what is the work that's been done in relation?
Oh, I see.
Yeah.
Okay.
Yes.
This might be more of a historical question, and maybe it's I hope it's a question, not a statement, but do you see it seems like the similarities with the eugenics of the 1920s are very strong here. Do you have a bunch of people who think they're working to a noble cause and working on a flimsy statistical base and coming out with complete garbage results? And have you compared it with eugenics, is my question, I guess.
Yeah, okay.
Yeah.
The answer is yes, but I'll take another question.
There was one right there, so Aaron, you may as well not even get up.
Okay. I'd claim there are trends of the reification of differences going on concerning other difference categories which are socially relevant, for instance, gender or sexuality. Mm-hmm. There has been attempts to try to find a gay gene, for instance, and so on. I'd be curious whether you would think that these trends and the ones you are focusing and working on are somehow connected, part of a same larger trend, or whether they would be distinct phenomena.
Mm-hmm. Can I do one more?
Sure.
There's in the third, I can't count, but third row back, right in the middle here, this chap with the glasses. I'm making it as difficult as I can for the ushers.
Right, as somebody who has personally experienced slightly different medical, when they ask you your ethnic group and then they say that you're more likely to have more diabetes and stuff, the problem is that the people who they make these medicines for are not involved in the process. So if say there's this drug for black people, which I actually object to, because genetics is about curing everyone, no matter what genetic background they have. How does this help empower patients and the communities to say no to this kind of thing?
Again, let me make sure I understand the question. That those who are suffering from diabetes, without regard to their racial category,
right?
And then?
Right, but how do we empower patients or groups who have this propensity for these higher rates of different conditions? How do we empower them to say no if they object to the nature of the medicines that are being given to them? Mm-hmm. So if I say I object to this particular medicine being given to my community, because to be frankly honest with you, I don't see what being of a particular ethnic background has to do with my health. I don't want to be going to my GP and being told, because you're black, you're going to get more likely to be a diabetic. I want a medicine for my diabetes, that's it.
Mm-hmm. Okay, let me try. I've got 4 different questions here. The first one has to do with I'll take the one on homosexuality first because that's, in some ways, that's the easiest one. There was a movement in the United States around this very topic where many in the gay community celebrated the discovery of the gay gene. And the idea was that if you, as a society, understood its genetic basis, there would be much more acceptance. That ties into the question on eugenics in a very funny way. It depends upon the context in which one makes this discovery. Not whether the I'll talk in a moment about whether the discovery had any validity. But what that misunderstood was that homosexuality is in always a context that's social, cultural, political, as in contemporary Russia. So you can't simply say this is a phenomenon to be understood genetically. It's whether or not it's expressed. And if it's expressed, to what extent are people going to be, in the era of eugenics, obliterated for it? People lost their lives during the period of the Third Reich for being homosexual. That's the same is true in contemporary Russia. A lot of operations which are going on which are really remarkable. Now, to the content of the question about whether homosexuality and genetics is a parallel to race and genetics. That was your question. There are certain important dynamics which are parallels to the two, but I see such sharp differences between them. First of all, in the last 20 years, there has been no progress in trying to understand the genetic structure or even the biomarkers or SNP patterns among gay people. There has just never been a corroboration of the early work of the 1990s. There were 4 important studies done 1990 to 1993. They have never been replicated. So on the substance of it, there is no evidence for or genetics of homosexuality. Some people, again, have thought that's a terrible thing because if they could just explain to their parents that it was genetic, then the problems would go away. Again, the naivete of that is that it's decontextualized socially. Eugenics. Yes, I'm familiar with that literature. And at one level, I think you have a point, namely people who were the eugenicists thought that they were doing the society a favor, not the victims of their analysis. Okay? So the eugenicists felt that they were like hygienists. Hygienics and eugenics were twinned. And if you got rid of poverty, those people who were dirty, then society would be better. So even Fabian socialists like George Bernard Shaw, the demographer, the woman who starts Planned Parenthood, you know who I mean. Yes, they were all, in some sense, eugenicists. But so was a whole high stratum of Western thought. Sweden, obviously Great Britain, Germany, United States, all had normal high-status people, professors, university presidents, who were all eugenicists, playwrights. And their conception was they were doing the society a favor by getting rid of those bad genes down at the bottom. That's different today. At least the framing is we want to understand how those people are having biologically difficult problems, whether it's Tay-Sachs, sickle cell, gene therapy. You know, we're going to help them with gene therapy. So we're not trying to get rid of them. We're trying to find medicines and pathways that are going to help them. That's the framing of many of my colleagues who are working on, quote, their own group. We're going to help those people as opposed to get rid of them. Okay. The other question was genetics and IQ? Yeah. The problem with IQ is, in part, its definition. And as long as we have a definition which has to do with performance on a test, the leap to the nucleotide is an extraordinary leap. So, for example, there's something called the Beijing's Genetic Institute. And they're now doing work on IQ and genetics. What are they doing? They're trying to find the best, smartest, brightest Chinese kids ever and take their DNA and hope they can find biomarkers, SNP patterns, which will be distinctive and permit us to understand for the first time ever the genetics of intelligence. But if you watch what they're doing with these young 8, 9, 10-year-olds, they come in and they take a series of tests, and they're the standard IQ tests. They have to do with the same thing we all experience, namely, there's cultural capital in IQ tests. That's the very nature of an IQ test is not just how can you think, but what do you know? And what do you know is socially located. So it's a flawed enterprise, but Beijing Institute has actually said out loud, we're going to do this because in the United States and in Western countries, they have qualms about this research. Here in China, we have no qualms about it. We're going to find the genetics of IQ by getting the 1,000 to 2,000 highest scoring Chinese kids, get their DNA, and find what? Biomarkers. I think it's a flawed enterprise for reasons having to do with the sociology of knowledge. Did I get everything? Homosexuality? An objective. I'm not forgetting Plomin. Plomin has collected over the last 25, 30 years genetic data on high-scoring students in the United States and Great Britain. And he is the parallel to the Beijing Genetics Institute. So they're comparing these two groups in order to find out commonalities inside the patterns of DNA. But of course, the basic problem with this framing is that we don't have any understanding of what part of the DNA is going to be relevant to, quote, intelligence. We have no understanding of that. The genome, maybe we're sort of at the end of the hour, 8 o'clock, so let me just say something about the genome and this whole framing. 3 billion base pairs. We thought there were 100,000 genes. Turns out there are only about 22,000 genes. In the whole genome, 22,000. Worms have that many. So what's happening with this difference is that it's not the gene, it's the proteomics, it's cell life, it's nurturance, it's epigenetics, it's all the things that cause phenotypical expression. That's what genetics is all about. The idea that you could go down to the gene for homosexuality or the gene for crime assumes that you could go to the level of the DNA and find this magical thing that was going to express itself in the most complex phenotype you can imagine, intelligence. So that's where a lot of this research begins with an assumption about the form and the power of the gene. And that is parallel back to genetics, to eugenics. That's a parallel, that somehow the gene explains things, when in fact in the last 80 years what we've understood, many of us who've been working in this area, is that it's the epigenetics. It's the phenomena outside the gene, outside the cell, the interaction between different forces that play inside the body, and then, of course, what's outside the body, the environment. That's a good place, I think, to end.
Thank you very much indeed for a robust session. Thank you.